Tharun Kshathriya and my registration number is 18BEC0180. I belongs to A1-slot. Today what I am going to discuss is there was a digital assignment which was given by my faculty Dhanbal. The subject is computer organization and architecture. If we want to complete this DMs, we need to select a microcontroller or microprocessor or IP core. Here what I selected is a microcontroller. Microcontroller is STM32F103C8T6. The vendor of the microcontroller which I selected is STM Microcontrollers, and it is a 32-bit microcontroller ARM Cortex M3. There are totally 10 questions in this digital assignment. First question is draw the clear block diagram of the microprocessor or microcontroller or IP core selected. In this case, I selected microcontroller, and here is the block diagram of the microcontroller which I selected. These are the individual blocks here in the sides. This diagram will be explained by me at the last by drawing in the online tool Draw.io. This is the detailed information about the block diagram. And the next, coming to the second B part, give the internal diagram of each and every block in the main system. Here this is I2C block diagram. This is system block diagram. This one is the pin diagram. This is the storage structure block diagram. All these block diagrams are present in the main diagram which I already shown at the starting. And then next, coming to the second question, provide the instruction set of the microprocessing element, microprocessor or microcontroller or IP core, with clock cycle required, machine cycle required, memory required, flags affected, type of instruction based on addressing modes, operation, etc. These are the commands, and this is the brief description about each and every command which is mentioned over here. And normally add ADC, add with carry, like this, branch B, branch BX, branch indirect, like this. There will be a commands and the brief description. This is the whole instruction set of microcontroller which I selected, STM microcontroller. And here from the question we saw asked memory access instructions also. So here are some memory access instructions of the microcontroller which I selected. ADR, load PC relative address, CLREX, clear exclusive, pop register from stack, push registers onto stack. And the next, multiply and divide instructions. Multiply with accumulate 32-bit result MLA means like this. And general data processing instructions. These are the commands. This is the brief description about each and every command which is over here. You can read about that. And bit field instructions. Same like this. BFC, bit field clear. This will clear the bit field. Branch and control instructions. Then next, coming to the third question, explain microprocessing element microcontroller architecture. System architecture consists of buses and general purpose DMA. What is meant by DMA means direct memory access, internal SRAM, internal flash memory, in which some of them considered as masters and other considered as slaves. And here are the blocks, masters and slaves, which I mentioned above over there. And then next, coming to the fourth question, correlate the microprocessing element, microcontroller, IP core architecture with the architecture discussed in module 1 and 2. Here we need to compare compare the architecture with the syllabus discussed in module 1 and 2. Okay, we can see here the ARM is reduced instruction set computer RISC architecture. Here, RISC architecture features. This and all are the RISC architecture features. The microcontroller which I selected is RISC architecture. There are two types of architectures, RISC and CISC. There are also differences there are also so many differences between RISC and CISC. Here are the some features about the RISC. It is a larger uniform register file, a load or store architecture where data processing operations only operate on register contents, not directly on memory contents. Uniform fixed length instruction fields to simplify instruction decodes. In addition, the architecture provides control over both the arithmetic logic and shift in most data processing. Like this, there are so many features for the RISC. Elaborate register organization of microprocessing element. Register organization. Here we need to discuss about the register organization. Here is the clear diagram of register organization. We can see here there are two types of registers, low registers and high registers. Here from R0 to R7, those and all are low registers, and from R8 to R12, these and all are high registers. These and all, the total low registers and high register, we can call it as general purpose registers. There are also stack pointer, link register, program counter. There are three special registers. Here you can see pre-mask, fault mask, bash spray, control. Here control register, exception mask registers, program status register. These are the special register, these three. And then next, brief description about each and every register, and the stack pointer, link register, program counter, and the special registers, status register. And these are the diagrams of each and every register which I mentioned clearly here. Priority mask register, fault mask register, like this. Explain the type of algorithm used for signed and unsigned calculations. Here subtraction, addition, like this. This is the operation. Add instruction adds the value of operand 2 or 1 into the Rn. Like this. These are the operations. These are the restrictions which we can't do. I have clearly mentioned everything here. These are the multiply and division instructions. Find what type of control logic unit used and correlate its performance with the type of control unit in module 3, the COA syllabus. Here also we need to compare both what I written and which I learned from the COA syllabus here. It is a hardwired control unit. There are two types of control unit: hardwired control unit, microprogrammed control unit. Here, for the microcontroller which I selected, it is a hardwired control unit, which is there all hardware architectures follow RISC instructions rather than CISC. So we know that RISC microprocessor has a hardwired control unit. So our microcontroller is hardware architecture, so it is a hardwired control unit. These are the differences for hardwired control unit, microprogrammed control unit. Speed is fast, speed is low, costlier, cheap, non-flexible to accommodate, more flexible to accommodate, difficult to handle complex instruction sets, easier to handle complex instruction sets, small instruction set, large instruction set. RISC microprocessor is the application, RISC microprocessor is the application. Control memory is absent, control memory is present. Chip area is less, chip area is more. Occurrence of error is more, occurrence of error is less. Complex decoding and logic sequencing, easier decoding and logic sequencing. These are the differences between hard controller unit and microprogrammed control unit. This is the best. We can see easily from the references. This one is efficient. Our microcontroller is RISC. Explain the memory management system in the process. Followed. Find the advantage of memory design and management techniques over the concepts given in module 4. Here also we need to compare from what I learned from what I wrote. Memory system, internal SRAM, direct memory access, boot modes, and all those things which are included in the microcontroller which I selected is already here, which I already wrote. And this is the diagram and a memory mapping model. I took an example and draw this thing. And the next, coming to the ninth question, elaborate the pipeline and parallel processing capabilities of the unit and hazard management technique. Here, pipelining. Pipelining is a process of arrangement of hardware elements of the CPU such that its overall performance is increased. Simultaneous execution of more than one instruction takes place in a pipeline processor. Here, what this means, we can execute more than one instruction at a time. That is pipelining. And stages of pipelining in RISC processor. This is instruction fetch, instruction decode, instruction execute, memory access, write back, and the microcontroller selected pipelining, parallel processing, work of the parallel processing, types of parallel processing, or single instruction, multiple data, multiple instruction, multiple data, like this parallel processing of the microcontroller which is selected, hazard management techniques which is asked in the question. We need to discuss about the hazard management technique also. Methods to deal data hazard management. These are around all the questions related to. And then next, coming to the 10th question, find whether parallel level parallelism is available in the element selected. Yes, it is available in the element which I selected, means which is microcontroller, STM microcontroller. There is a parallel level parallelism, and also illustrate a cache coherence and protocol used for handling memory hit or MISS. Cache coherence. We need to cache coherency is an important concept to understand when sharing data. Disabling cache can impact performance, software coherency, adds overheads and complexity. Like this, there are three mechanisms to maintain coherency. One, first method, then second method, third method. Cache cleaning. If you need to clean the cache, means we need to do this, like flushing, cache invalidation, like this. This is the miss. Hit. An access to an item which is in the cache is called hit, and an access to an item which is not in the cache is a miss. This is the block diagram from which we can easily see all those things. This is the end of the 10th question. Now what I'm gonna do is, I will draw this block diagram in the online by using the draw IO tool.